Hey Bio20s, I just wanted to quickly chat about enzymes as you are adding them to your notes today. So here I have designed an enzyme that is matching with just a substrate. Of course, just a little drawing made up. This isn't really showing much. But what it is showing is the three key pieces that with an enzyme and a substrate, you need what we call the activation site. This activation site is where you are going to have that enzyme binding with that substrate because they match perfectly. This matching, I guess you could say match made in heaven, we refer to as the lock and key. Kind of think of it like your house key, your car key. People don't have those. You can't get into your friend's house with your key because your key is specific to your house. And that's how enzymes and substrates work, is they bind together because they're designed for each other. Now the activation site is where it goes to bind. And when it does, it helps break apart any macromolecule in our body for digestion. For example, sucrose into glucose, or polypeptides into dipeptides into amino acids. The idea is that enzyme is activated and helps break apart the parts bound to the substrates. Now, enzymes are extremely important because they lower what we call the activation energy in digestion. So let's pretend without an enzyme, eating a piece of bread takes you 15 hours to digest. It's a long time. What happens is the enzyme helps break apart that process by binding, lowering the activation energy so that the process starts sooner and may not have to last as long. Now, enzymes are also designed to be part of the digestive process. So we are going to learn a ton of different enzymes, or you've already started to learn a ton of different enzymes names that are playing a role in your body right now. What else I want to quickly talk about is what enzymes are made out of. So although this is what it looks like, if we were to take the enzyme and break it down, it's actually just a protein. And we know that proteins are made out of long chains of amino acids. And these amino acids are in different shapes. And when we put them together, sometimes they can look like this, or sometimes they can look like that, okay? They're just long chains of amino acids. But because they're made out of proteins, they're actually very, very vulnerable to certain situations. And enzymes only work in certain pHs and certain temperatures. So if you think about our body, the enzyme in our stomach, pepsin, is activated at a pH of 2 and at body temperature. The enzyme in our mouth, salivary amylase, is activated at a pH of neutral, 7 to 8, and a temperature of body temperature. What happens to enzymes when they are exposed to a high temperature, such as 104 degrees, okay? They start to go through a process called denaturation or denaturing. Denaturing causes it to break apart and unravel, which is a really bad thing because if this is this enzyme, it now doesn't fit with its substrate and it can't break things down. So denaturing a protein like an enzyme can have massive effects. If you go to the hospital and you have a huge temperature, 104, 105, 106, the proteins inside your brain actually can start to denature and you can actually cause yourself brain damage with a very high temperature. It's quite dangerous. So what I want you to add to your notes today is what is denaturing. Sorry, I bumped my camera. So we're going to define it, and I would like you to add it into your notes today. So we are going to say that denaturation, or like I said, denaturing, is the unraveling of a protein. All right, so in the simplest forms, that's what you're going to put in. I'm going to try and find a couple demo examples of denaturation. It is a very important concept to understand, so please put it in your notes, add it in, and I will talk to you soon.